Hello friends, welcome to the fifth tutorial of this series of Excel tutorials of data analysis. Now in this tutorial we will be doing the chi-square test. We have the observed number and we have the expected number over here. Since we have the six entries for the roll, this is the case of rolling a dice and we have the six outcomes, and these are the observed numbers and these are the expected numbers, and we are doing a chi-square test. I have shown you the formula for the chi-square test, and we have created the two hypotheses over here. We have the null hypothesis, that there is no difference between the expected and the observed numbers, and the alternative hypothesis is there is a difference between both of these numbers, both of these observed number and expected numbers. Now let us see what is the significance of the chi-square test. Now what is the significance of the chi-square test? You can see that the chi-square test is used to determine whether there is a significant difference between the expected frequencies and or not. So this is the significance of chi-square test. It is used to determine whether there is a significant difference between the expected frequencies and the observed frequencies or not. So in this case we have also here created the two hypotheses over here. So we will now start doing calculation, and we will calculate the chi-squared value for the given observed and expected numbers. So first of all we will have to calculate the deviation. The deviation is O minus E, that is, we will putting an equal sign, and this minus expected number. So this is the value for this column, the deviation, and we can calculate these numbers. The next step is to calculate the deviation squared, that is, which is equivalent to the square of the deviation. So we can get the same deviation squared for all of the six entries in the same way. Now in the next step we have to calculate the deviation squared divided by the expected number. So to do this, what we have to do is click over here and divide it by the expected number. So we have calculated this parameter, and we can calculate this parameter for all of the entries in the same way. So now to calculate the chi-squared value, we have to just create a summation of these numbers. So that will be our chi-squared value. So these are the variables that we are considering here. That the alpha value is 0.05. That is, we are considering a confidence interval of 95%. So that is why the value of the alpha is 0.05, and the degrees of freedom is 5. As you can see that there are the sixth number of observations, so we have the n minus 1 degrees of freedom. So we have the 5 degrees of freedom. So now we will be calculating the chi-squared value. Like I have calculated it already. I will show you how to do it. Like you have to just sum all of these values, because that is the value of chi-squared. So to do this, click over here, and you have to sum all of these values, and you have to click over here, plus you have to add all of these values, and that is our chi-squared value. Now so this is the value of chi-squared, and that is the same value that we have already over here. Now we have to check the critical value of chi-squared. That we can see that we have the alpha value of 0.05 and we have the degree of freedom of 5. So we can calculate the critical value from here, like the chi-square table. This is the table for chi-square statistics, and we have the value of p, that is alpha, equal to 0.05, and we have the degrees of freedom of So the value of degree of freedom in our case is 5. So the value of p is 0.05 and the corresponding value of chi-square statistic is 11.07. So this is the value that is the critical value, 11.06. Now, since the chi-squared value is less than the critical value, so we cannot reject the null hypothesis. That is, we can't reject the null hypothesis. So we can't reject the null hypothesis. Now, if we calculate the same thing with the help of an Excel formula, we can also do same with the help of an Excel formula. Like you can do this by clicking the formulas cell over here, and you can search for the formulas. Like we have the statistical formula, and you can go for the chi-square test. It is here. So you need to provide the actual range. The actual range is the observed numbers. You need to provide all of these 6 entries, and again you need to provide the expected range, that is expected numbers, and this is it. And now you need to click on the OK to get the parameter value. So click on the OK, and the value is 0.45. So actually this is not the value of, this is not the chi-squared value, this is the p value or probability value for the chi-squared. And since we can see that this probability value is 0.45, and the alpha value is 0.05. If these probability value would have been lesser than the alpha value, then we would have reject the null hypothesis. That is, there is no difference between the observed and expected numbers. But since the probability value of chi-square is greater than the alpha value, so we cannot reject the null hypothesis over here. So in this case, we have also used the Excel formula, and we cannot reject the null hypothesis since the probability value is far greater than the alpha value. So in this way we can do a chi-square test for the given data set, and we can assume the two hypotheses, the null hypothesis and the alternative hypothesis, and based on that we can carry out the chi-square test, the Pearson chi-square test, which is also called the goodness of fit test, which is used for the significance, to calculate the significance between the observed and the expected numbers. So in this case we have conducted a chi-square test, and we cannot reject the null hypothesis. I hope this would have been clear, and thank you.